Alright, so I coded up a different version of the problem from Friday. Or actually, sorry, I coded up the problem from Friday that I was watching the video on. I didn't code the solution, I just watched the video. This time I coded the solution. It was the path you have to take to climb up a set of stairs where each stair has a monetary value and you have to minimize the uh, price of the path, right? So before you would just output the price, but the little twist in this version was to actually go back and find the path that you took. So this code works by doing the same thing basically. In this for loop, it finds right here, it defines a DP array and then defines the ith index of the DP array as the minimum of the previous two, because you're only allowed to take two steps, plus this price array, which is defined by whatever program. I just hard coded some random values. The price at I, right? So the minimum, the value of the price of the ith stair that you're on is equal to the minimum of either the I minus 1 or I minus 2. So the minimum of where you came from plus the price of that stair. And then it added this little part where this from array, you create this from array that basically tells you where the index I is from. So if you were on this step right here, it would tell you that this step is from here, right? Because you would never go from here. It would always be from here to here, because you would never go from 7 to 2, because 7 is a higher number than 2, right? So that's what it's just doing here. If dp I minus 1 is less than dp I minus 2, from is I minus 1, else from is I minus 2. And then you define another array. I did a vector because it just makes it easier, called path. And then backfill the path vector with the indexes from the from array. And it's actually kind of interesting. The way that you update I is by taking the ith element, right? Because I is always equal to n, because n is the number of stairs. So you're always going to be from 7, or the 7th stair there, however, whatever n is defined to, right? N is 7 in this case. And then as long as I is greater than or equal to 0, and then if I is 0, you break, obviously. But then to update the I, you set it equal to your from I, right? So the array, if you're at here, if you're at the last element, because you start from the last element, right? Where is that from? And that would be from here, right? So actually, no, sorry, in this case it'd be from here, because you go from here to here to here, right? So that's reflected in the output, right? 7 to 5. And so I is not like incremented by minus minus, which is how I think I would usually do it, like in my mind, but it's just like set equal to an array that's previously defined. So then the new value of I would be 5, and then from like I5, right, that would be 3, right, which would be this index right here. And then just, yes, print out the values. And then you could reverse this list as well, because that would be the proper way to do it, but I didn't do that this time. So yeah, this kind of updating I condition is something that I'll keep in mind for later problems, because I think the guy said that's something that is sometimes useful for certain problems, and I guess like I never even would consider doing that, but I guess it definitely makes your code more efficient and less like wordy overall.